so today we're going to do the Boyle's law experiment. So this is going to be a two-part video. So the first part will be studying about the isochoric heating. So a little bit of an introduction. So air is something that we cannot see, but it has properties that we can study, like the mass, the volume, the temperature, the pressure. So what we're going to do now is we're going to study the relationship between some of those elements. And for this experiment, so we're going to study the effect of temperature towards the pressure inside the closed vessel. So here we have one closed vessel. So inside here we actually have a normal air. So this is a closed chamber. So we have one discharge valve here. So this discharge valve controls the open and closing of the vessel. So if, let's say, the valve is closed like this, the vessel is completely sealed from the outside environment. So let's say if I open the valve here, okay, so now all this is exposed to the atmosphere. So it has an atmospheric pressure around 1 bar. All right. So also up here we also have the temperature sensor here, labeled by the green white sensor, and also we have a pressure sensor here. Okay, so on the right side here we have the temperature controller. So this is the way that we are going to control the temperature inside the closed vessel. So right now we set it to a maximum of 80 degrees Celsius. So right below here we actually have the pressure reading. So it's the measurement is in bar. So right now we have an ambient pressure of around 0.99 bar, which is approximately 1 bar, the 1 atmospheric pressure element. So now below here we actually have the heater. So when we turn on the heater here, we can see the pressure inside will also increase. So we're going to study on how the temperature affects the pressure. So we can actually see the relationship between the temperature and the pressure of a gas inside a closed vessel. Okay, so now I'm going to show you how to run the experiment. So for isochoric heating and cooling, it's fairly simple. So the first is you need to set up everything. So first thing you need to do is actually you need to open this valve to make sure that this vessel has the atmospheric pressure inside the vessel. So once you open it around a few seconds, then you need to close it back. Okay, once you close it, now you are ready to heat up the air inside the vessel. Okay, so for this experiment you need to have at least one stopwatch, because we're going to take the reading at every 1 minute. Okay, so once we turn on the heater here, okay, we're going to start our stopwatch. So every 1 minute we're going to take both the temperature and the pressure reading. Okay, so what I'm going to do right now is I'm going to start the heater, and also I'm going to start my watch. Okay, so now it's running. So we're going to wait around a minute before we can take the pressure and also the temperature reading. Okay, so now it's 1 minute. So the pressure and temperature is 31.1 and 1.06 bar. Okay, so now we're going to wait for the second minute. So we're going to repeat this process until the 7th minute, or until the temperature reaches 80 degrees Celsius. So which ones comes first? Okay, on to the second minute. So the reading is 37.1 and 1.11 bar. So you need to be precise when you take the reading. So repeat the process up until the 7th minute. So you need to make sure that when your stopwatch reaches the minute that you need to take the reading, you need to take the reading as accurately as possible. Alright, so the heating process is completed. So we have all the reading that we need. So up till the 7th minute, so it exceeds the 80 degrees Celsius threshold, but that is okay because we still have the data that we need. Okay, once we get all the data after the heating process, what we're going to do now is we're going to release the pressure inside this vessel. Okay, so what we're going to do, I'm just going to release here. Okay, so as you can see right now, the pressure here is now an atmospheric pressure of around 1 bar. Okay, so the next step is we're going to wait for the temperature to drop below 80 degrees Celsius. So I'm going to turn off the heater now. Okay, I'll wait for the temperature to drop until 80 degrees Celsius. I'm going to close back the discharge valve, and we're going to continue with the cooling experiment. Okay, right now the temperature is going down from 80 something towards 80 degrees Celsius. So I'm going to shut off the valve and start my watch. Okay, so I already started my stopwatch. So we're going to wait for the first minute, record both the temperature and the pressure. So we're going to see what happens to the pressure once the temperature goes down. Okay, so we're approaching the first minute. So we're going to take the reading. 77.8 and 0.8. Okay, so what we're going to do now is we're going to repeat the reading at a 1 minute interval, and we need to take at least 12 readings or until the temperature goes back to ambient temperature. So it's going to take a while, maybe in a few minutes, but we need to stay on track and make sure that every 1 minute interval we're going to take the reading so that we get the most accurate data that we can get. Okay, so we're approaching the last minute, so it's the 12th minute, so I'm going to take the final reading. So 57 and 0.2. Okay, so now we've recorded the heating data and also the cooling data, so we can actually see the relationship between the temperature and pressure for both cooling and heating. Okay, so do refer to your lab sheet on what graph you need to do. Okay, so we have you can also fill in directly your data directly here. So I just did for safety reason I just wrote down my data on my notebook here, but you can write it down directly to your data sheet. It's no problem. Okay, so you need to do your discussion, and as I mentioned before, this is a two-part experiment. So what we did was the isochoric heating and cooling. So for the next part of the video, we're going to see the isothermic compression and expansion. Okay, so alright, so that's it from me right now. Thank you so much. So don't forget to complete your lab sheet and your lab reports, submit it, and have a good day everyone, and thank you. See you again in the next video.